Hi everyone. So today we're going to go over the relative dating quiz review and we're going to go over the answers in this video. So let's get started. This is question number 1. The correct answer for question number 1A is G, Z, E, S, F. G being the oldest and F being the youngest. So remember your two of these laws of relative dating. The first is the law of superposition, which means that the oldest layers are going to be in the bottom and the youngest layers will be in the top. And the law of cross cutting relationships tells you that any fault or any igneous intrusion that cuts across the sedimentary rock layers will be younger than the sedimentary rock layers. So the horizontal layers are sedimentary rock layers and unconformities, as well as volcanic ash layers. If a fault or an igneous intrusion cuts through these layers, or the volcanic ash layer, or the unconformity, then the fault and the igneous intrusion will be younger than the layers they cut across. So let's get started on figuring out the why the answer is this. And I like to start from the bottom to figure out the sequence of events that happened. And you can see that G is the sedimentary rock layer that got deposited first, and then it looks like Z is an unconformity that eroded away, weathered and eroded away rock layer G. I know Z is an unconformity because in the top it tells me W, X, Y, and Z are unconformities. Index for fossils are represented in two of the rock units. Volcanic ash layers are labeled. S also says is a fault. So G got deposited, then Z is an unconformity that happened, then this volcanic ash layer got deposited, then E got deposited, and then it looks like Y is an unconformity that happened, and finally S is a fault that cuts across all these layers, so S must be younger than all the layers that it cuts across. And then it looks like this layer got deposited, and then this layer, and then this layer, and then this layer. And then it looks like F is an igneous intrusion that cuts across all those layers. I know F is younger than all of these layers because it cuts across those layers. Any fault or igneous intrusion that cuts across sedimentary rock layers or other layers are younger than the layers that they cut across. So that's why the correct answer is G, which is the oldest, then Z, E, S, F. So question number 1B, the correct answer is 387 million years ago to 435 million years ago. If your answer is any of these answers or any numbers in between these answers, your answer is correct. And the question asks, based on the index fossils found in the rock units A and D, here's my index fossil from unit A, and this is my index fossil from rock unit D, determine approximately how many million years ago unconformity W happened. So I can figure out the age of these index fossils from reference table page 8 and 9. And if I know the age of these fossils, then I can know the age of these rock layers. And if I know the age of rock layers D and A, I know W is an unconformity that should have happened or should be an age between these rock layers, right? It should be a number between the age of A and the age of D. So let's go to reference table page 8 and 9. And these two fossils right here are actually my fossils Y and Z. And if I find Y and Z on my reference table, page 8 and 9, I see that Z's age is somewhere around here, around 387, and Y's age is somewhere around here, around 435 million years ago. So the unconformity W's age must be a number in between those two ages. That's why the correct answer is 387 million years, any number between 387 to 435. So question number 2A is showing that the diagrams represent drill core samples from two different locations, 1 and 2. Drill core samples are basically a device that we use to drill into the earth and take out cores of the earth, like kind of like this almost. And that helps us see the layers of the earth to figure out how old the rock layers are. So it basically taking out a cylinder of the earth to earth's crust, not the crust, yeah, the sedimentary rock layers, to figure out the ages of the rock layers. So A says, identify actually, let's finish reading this. A drill core is a cylinder of rock material removed from the bedrock. So that's what a drill core is. Letters A through J represent different rock layers. Um, I cut a lot of this off actually. So it should say sedimentary rock layers contain some rock layers contain index fossils, and the rock layers shown have not been overturned. Identify the geologic period when rock layer A was deposited. So the biggest hint here are my index fossils, right? So rock layer A, to figure out the age of rock layer A, I should figure out the age of my index fossil in rock layer A. And to do that, I should go to my reference table page 8 and 9. And it looks like the index fossil is fossil B right here. And fossils B's age, or the period of time that fossil B came from, is the Ordovician period. Now, please don't say middle Ordovician period, because if you said middle Ordovician, that would become an epoch. And the question is not asking you for an epoch, it's asking you for a geologic period. So your answer should only be Ordovician period. If you said middle Ordovician period, it would be wrong because it is not asking you for a geological epoch, it's asking you for a geologic period. Okay, so question number 2B, the correct answer is EDGF. E is the oldest, F is the youngest. So this one's a bit confusing because there are so many unconformities present in both these locations. So the biggest hint that you should look at are the index fossils. The index fossils, there's one index fossil here, and there's another index fossil in location 2. So let's see if the ages of these two index fossils match up from my reference table page 8 and 9. And if I look at my page 8 and 9 reference table, I see B is this fossil and D is this fossil. And both these fossils are actually the same age. They're both from the Ordovician period. And that's a big hint. So I know A and H because of the fossil's presence, or the index fossils present in the layers. I know A and H must be the same age. That means B and I think this is I, yeah, B and I are also the same age. And look, the sequences match. The rest of the sequence don't really look like they're matching because of all the unconformities present, but that's okay. We have a reference point between locations 1 and 2 to help us see, okay, these two layers must be the same age, meaning anything above these two layers must be younger and anything below these two layers must be older. So that's why the oldest rock layer is E, which is because it's in the very bottom, and then D is the second oldest, and then we have these two layers which are the same age, which makes G the second youngest and F the youngest. So the correct answer is E, D, G, F. Okay, so number 2C asks, identify two processes that form the unconformities in these drill cores. So anytime it asks for unconformities, please go back to your note packet and look at this area. Unconformities, the four ways that an unconformity forms is deposition, uplift, weathering, erosion. Memorize this, and this is only asking you for two of these processes, so pick any two of these and write that down here. Okay, number 3. Which pie graph is shaded to best represent the approximate percentage of time that humans have existed during Earth's entire history? The correct answer is A, because for any question that asks how long humans have existed during Earth's entire history, we've only lived for or have existed for a very short period of time compared to most of the things that happened in Earth's history. And that's why the correct answer will always be the shortest amount of time possible, the shortest or the smallest number possible that they give you in your options. So in this case, out of all of my options, the smallest amount of time is this A. So I'm going to pick A because humans have not existed for that long. And there's evidence of this in your reference table compared to everything that has happened in Earth's history from this 4,600 million years ago to the present. Humans have only existed for a very short period of time, around 0.01 million years ago. So, number 4, most of the oceanic oxygen that began to enter Earth's atmosphere in the early Proterozoic era was probably produced by, the correct answer is B, photosynthesis by cyanobacteria. And you can find this answer in your reference table, page 8 and 9, right here. Here's the early Proterozoic. It says oceanic oxygen began to enter the atmosphere around this time. But to find out what caused the oceanic oxygen to enter the atmosphere, you just look back a bit over here, and it says oceanic oxygen produced by cyanobacteria. So that's why the correct answer is B. 5 asks, the map below shows the inferred shape of North American landmass in the past. The location of Florida is labeled. So here's Florida. Which event was occurring on Earth when Florida was located at the equator? The correct answer is B. The earliest dinosaurs appeared on Earth. So to figure this answer out, I should go to page 8 and 9 of my reference table, and I should find out around what time this part of North America, Florida, was at or around the equator. So if I go to reference table page 8 and 9, I see that that part of North America, Florida, right here is at the equator around this time. And if I go towards the left side and I check all my options that they gave me, I see that the earliest dinosaurs actually existed around this time. That's why the answer is B. The earliest dinosaurs appeared on Earth. Number 6, the gases in Earth's early atmosphere are inferred to have come primarily from. The correct answer is C, volcanic eruptions. This is something you're going to have to memorize, and remember that in the early Earth's early atmosphere, it was very hot and there were lots of volcanoes, and those volcanoes were spewing out gases like carbon dioxide, nitrogen, and water vapor. The only gas that was missing, or the one gas that's important for us that was missing, is oxygen. And oxygen later came about or entered our atmosphere from cyanobacteria. Today, cyanobacteria could be compared to blue-green algae in the oceans, and even today blue-green algae produce most of the oxygen that is in the Earth's atmosphere. So oxygen came from cyanobacteria, and most of the gases before that came in the Earth's atmosphere came from volcanic eruptions. Also, please remember that another thing that comes up on the regions a lot is that dinosaurs went extinct or are believed to have gone extinct from an asteroid impact on the Earth. And that asteroid impact from the Earth created lots of debris that went into all over the world into the atmosphere, and it caused the blocking of sunlight. And since sunlight was being blocked, it created what we call a nuclear winter, and the dinosaurs and lots of other species actually could not really handle that change in environment, so that's how they became extinct. Anyway, question number 7. Fossils of which type of animal would most likely be found in the surface bedrock of Catskills? The correct answer is B, brachiopods. So if you see the word Catskills, you should go straight to reference table page 2 and also 3. So if you go to reference table page 2, Catskills is right here. Catskills is part of the Allegheny Plateau. Catskills is a plateau as well. But if I compare the Catskills to page 3, I see that the Catskills should be around here, and this area of New York is actually, or the bedrock of is actually from the Devonian time period. And now that I know what time period it's from, I can figure out which of these organisms lived or existed around that time period. That could tell me which fossils of which animal is likely found in that bedrock. So to figure out which fossil it's going to be, I should go to page 8 and 9 and find the Devonian time period and see which fossils existed around that time period. So if you go to page 8 and 9, here's the Devonian time period. From all my options, reptiles aren't really around any of the bars around here. Reptiles became very popular around the Permian time period, so that can't be it. But brachiopods have existed since Cambrian time period to the present. Mammals have only existed much later, around the late Triassic time period, and birds have only started existing in the late Jurassic period. So the correct answer must be brachiopods, because we must have found fossils from brachiopods around that time period, especially fossil Z. Number 8, one characteristic of a good index fossil is that the organisms that produce these fossils is the correct answer is B, lived over a wide geographic area. The reason is, remember, index fossils have three properties, right? Remember, saw, short lived, abundant, widespread. And that's why B matches that, because that fossil must have lived in a widespread area, wide geographic area for it to be considered an index fossil. Number 9, which group of organisms survived mass extinctions that marked the ends of both the Paleozoic era and the Mesozoic era? The correct answer is D, gastropods. So if I'm asked about fossils and if I'm given things like eras, then I should go straight to my reference table, page 8 and 9. And if I go to page 8 and 9 and I find the Paleozoic and the Mesozoic eras, and I look for all of these options, here are ammonoids, graptolites are right here, Eurepterids are right here, and gastropods are right here. These are the bars for these organisms. And remember, we read this from bottom to top. The bottom parts of the bars are when those animals or organisms came about or started existing. And if the bars stop at any point, that means those organisms went extinct. Some bars never stop because they still exist today, such as corals, birds, mammals, etc. So, if I look at the end of the Paleozoic and the Mesozoic, it looks like gastropods existed around both those times. For Eurepterids, they went extinct right before the Paleozoic era. Um, the graptolites went extinct around the Paleozoic era, and the ammonoids went extinct right at the end of the Mesozoic era. So gastropods are the only ones that survived the mass extinctions. And that's it. Thank you. Bye.